It's the SG Podcast. Today, the podcast, we have El Stahura.
Hello.
We have Leif Bjornsson.
Hi.
And Brian Cofield joining us.
Hi there.
And I'm Kyle Bacher. And Leif and Brian are from our Java practice. And today, they're going to school us on machine learning, because I certainly don't know what the heck it is. I think El knows more about it than I do. You know, maybe to start with, pretend I'm a caveman and tell me what machine learning is.
I like to think of it as like three different pieces fundamentally. There's like a training bit and a model bit, and then like your outcome or your prediction. The training bit, like I'm sure you've seen a bunch of examples where like you feed in cat pictures into your machine learning program and you tell it, this is a cat, this is not a cat. And then it builds up the next part, which is the model. And the model is trained based on that input data of cat, not cat. And then based on that, you can get new pictures. And then the model will predict whether that new picture is cat or not cat with some credibility, 95, 98. And then the better the probability, the better your model is, the better it fits. I don't know. What do you think, Leif?
Yeah, that's a good example. I guess if we're starting from caveman, we should probably start with electricity. So should I start there, or do you want me to jump?
What's an electron, Leif?
Yeah, can you explain binary?
Caveman would ask. What's an electron?
Yeah. So I mean, in simplest form, I think it's basically we're teaching computers to learn from data without being explicitly programmed, right? So if you think about solving a problem algorithmically as you would as an engineer, right? Like you're writing some algorithm, writing some code that's going to, like in Brian's cat picture example, somehow analyze the pixels of an image and look for certain characteristics. That would be a really difficult problem to solve programmatically in the traditional computer science. But with machine learning, the computer is learning that task for you.
Oh, go ahead. Sorry.
I was going to say, it's sort of like when you think about baking something, like the traditional computer programming approach would be, here's the recipe, you do this, and then you do this, and you do this, and then you get flan out of it. But with machine learning, you're showing a computer, okay, this is a flan, and this is a flan, and this is a flan. Now you figure out how to make it. And so the aim is to try and get a formula or a recipe that is generated just from the end result. So how do you get to the flan at the end, with the hope that you get a perfect recipe? You don't always, but that's the goal, is to be able to accurately create a flan or accurately identify a cat picture.
Oh, careful. You're getting into generational AI here, I think.
So that's a good so that's a good lead in, like, is machine learning the same as AI?
No.
It's technically a sub, I guess it's technically described as a sub-discipline of AI. So AI encompasses machine learning. Yeah.
So it would be part of AI, it would be doing machine learning.
Machine
so
learning
basically,
is all AI, but AI is not all machine learning.
Yeah.
Right.
To finish up, just to make sure I understand it right, programmatically, you'd have to say these are the characteristics of cats. If you see them, it is a cat. Or you have a giant database of all cats, and you say each one of these is a cat. If it's not one of these, it's not a cat.
It's somewhere in the middle there. You basically have a giant database of cat pictures and not cat pictures. And you think of it, you're training an infant and you show them a bunch of pictures. Okay, this one's not a cat, buddy. All right, but this one is. And then they go in the real world and they see a lynx, and they're like, pretty sure that's a cat. Kind of looks like one. So it does some inference based on some magic neural network. Obviously, toddler is more complicated than machine learning, but.
And then as the machine runs, like at some point, it's off and running, like out in the world, just recognizing cats. And does it always improve as time goes on?
No.
You have
No.
to retrain it with bigger data sets or different data sets. Yeah, sorry, go ahead.
Yeah.
Like,
Oh, I mean, so I guess my answer would be it depends. It depends on the environment that your model is living in, right? So if we live in an environment where new species of cats never arise, even like they're always they always have the same surrounding in their pictures, like that kind of thing, then your model, I guess, potentially would never degrade. But generally, we don't live in a static environment, so eventually a machine learning model, its performance will degrade, and if you're not monitoring that performance, you won't really know, which is kind of one of many challenges with successfully deploying machine learning over the long term.
Yeah, and I know, Leif, you've done a couple presentations at our big event that we do every year, and correct me if I'm wrong. I think one of the things that you talked about, I think in 2019, was that there was a machine learning model to identify wolves, and it seemed like it was really, really good at identifying if the picture presented was a wolf. And then as additional images started being fed to the machine learning algorithm, all of a sudden the researchers kind of noticed, oh, it labels something as a wolf if there's snow in the background. So as long as there's snow behind the wolves, then yes, it sees a wolf. But if you're showing a wolf in a zoo or a wolf in someone's living room, it was horrible at it. So I think that was a really good example of how if you're living in a static environment, your algorithm is going to be pretty good. But as soon as you start bringing in some kind of change or variety that you haven't accounted for in your test data, that can be a problem.
right, and to that point, when you notice that your machine learning is algorithm, when your model is doing something not quite right, you would add pictures of wolves not in snow to your test data set and retrain, and then you'd get a better, more refined model that can handle other types of wolfy pictures.
But the key here is you're getting to a tolerance of like 95, 96%. So it's getting you quite a ways toward your goal. And then you might have some outliers that you have to account for. But it's moving the ball forward. It's worthwhile, right?
Yeah, so I guess besides the joy of being able to accurately predict whether there's a cat in a picture or not, why would people want to use that, particularly at employers, aside from obviously cat photography studios?
I mean, generally, I'd say it's you want to make sure you have a sufficiently complex problem that's well defined. I mean, are you looking for specific use cases or or examples of a general use case? So, okay, so in general, you'd want some sufficiently complex problem, and have sufficient data that you could actually apply to it, right? So that's kind of, if you haven't defined your problem and you don't have the data, then you might not be time for machine learning. Some examples of common types of problems that you'd solve, something like personalization. So let's say it's like in an e-commerce setting, giving different users different experiences based off of something we know about them, recommending certain products, detecting anomalies, so like fraud detection. If you ever get a notification from your credit card company, hey, this looks like something you wouldn't buy, that type of thing. That's all machine learning. They've learned what your spending behavior is, and they're going to notify you if they see something that looks out of the norm. Chatbots for support, right? Automated customer service type thing. You can train a chatbot using machine learning. Image video processing, like we talked about, identifying images. I don't know. Brian, good.
Well, that's a comprehensive list. I think self-driving cars is kind of the elephant in the room right now. We're trying to get towards
Yeah.
with this approach, and that's why you fill out all those captchas. This is a bridge. Is this a stoplight? Is this a car? So that we can get that training data set, a large training data set, to the machine learning algorithms, so they can be better at not, harming pedestrians while they're driving.
Is that true? Are they actually using those captchas so that we can help train machine learning?
Absolutely, that's their primary purpose. Well, that and keeping
That's
robots
diabolical.
out of the
You're labeling images for them.
Well, and I think AI gets a bad rap sometimes, and it should, because it might be misused. But maybe we'll get into that later. But when you're saying, Life, about e-commerce sites knowing something about you, I want to make the distinction that it's not like the machine learning algorithm goes, oh, this is Leif. I know what Leif does. It's more like Leif looks like 1,000 other users that kind of do the same thing, and so we can personalize based on a generality. Like you kind of fit that type. Like maybe you really like Apple products. Next time you come in there, okay, we'll put you in the Apple bucket. So it's not as creepy as, okay, I know you personally.
Yeah, they don't care that much about you. Yes, that's right. No, I mean, and in general, like a machine learning model is only valuable if it can generalize, right? If you've, and this is, I guess, to use without using too much jargon, hopefully, if you've overfitted your model so much to the data set that it only works on that data set, or it's at the point of targeting a specific individual, then it's just not going to generalize, and it's not going to be successful when you deploy it.
So can we talk about that a little bit more? And would you mind maybe explaining a little bit more what you mean by getting the model to fit the data, or why overfitting is a problem?
Sure. So let's see. Trying to think what a good example would be. If you're, I guess, well, one canonical like machine learning data set maybe is like the learning. You want to learn or predict the price of a home based off of a bunch of different characteristics about it, right? Mm-hmm. And so let's say like the most of your data is following some pretty linear trend line, right? If you think about like a linear regression, right? You gotta maybe like
number of bedrooms,
number of bedrooms and price on the y-axis, number of bedrooms on the x-axis, and it's pretty linear. But then you have a few outliers, right? You're going to have some outliers in any data set. If you train a model that basically you have a trend line that goes through each one of your data points, including those outliers, your model isn't going to generalize very well. You're going to have some really wacky predictions if you just happen to hit one of those spots where you've overfit. So it's a balance between generally it's a balance between accuracy of your model and how well it's going to generalize, right? So if you go for 100% accuracy, it's not going to be a good model because you've hit every one of your data points and yeah.
Yeah, no, that makes sense.
Anybody else have anything to add to that?
I'm just imagining, like, on the AI side of this, like AI gone wrong would be, where the AI builds a self-robot body and then goes out, and because its job is to identify cats, when it runs out of cats, it starts like trying to make dogs into cats, and then just mayhem ensues from there.
So this is a good point, Kyle. This is the Terminator style AI. It's a Skynet.
This is awfully bleak.
with our current, I'm not going to say that's impossible, but with the things that we know today, that's not possible with current technology unless some, clandestine group has figured it out and hasn't told us. But that's not possible with the tools we're using. Really, it's
those details to himself.
Yes. We're really limited to training it for a specific purpose or goal, and like Leif was talking about earlier, you have a basically a purpose that you need to do, and you train it for that, and it can be really good at that, but it's not going to go and go off the handles. I mean, I guess you could put a kill switch if you're worried about that, but
So, like specific things come to mind where you don't need 100% accuracy would be like product suggestions. You know, if they bought A and they bought B and other people bought A, B, and C, that person will probably buy C as well.
Yeah, in that case, you are playing the probabilities, and the goal is not necessarily to get everyone to also buy C. It's just to increase the chances that, you know, if you put it in front of them, that, you know, they will have wanted to buy that in the first place and say, oh yeah, that's just right here.
Because your space on that shopping cart screen is limited. So you want to bubble up the most likely things to get that additional sale, that add-on. Are there other specific things that you've done with machine learning?
Q-Life.
So I would say in a professional setting, it's primarily been driving personalization, optimization. You know, like we talked about, like that use case of we have limited real estate. As a user is viewing some screen, what do we want to show that user? Personally, I dabble in machine learning for music, so that's kind of for fun rather than profit. And that's really interesting space. There's a bunch of cool work going on there, generating melodies, generating drum tracks using some machine learning model. Anybody interested in that, I would encourage you to check out the Google Magenta project. It's an open source project with a bunch of cool stuff, not just for music, but generative art as well.
So when you're talking about machine learning with music, I want to circle back to what you said earlier about machine learning is good when you have a specific problem to solve and enough data for it. So how do you go about finding the problem to solve if you want to explore music and machine learning? So
I guess in terms of, I'll think about some of the models that are in this Magenta project in particular. Yeah. So those are, let's see, those are they're generative models. The goal is to, your goal is to generate some melody or some rhythm, something like that, which ends up being some MIDI sequence. MIDI is just a way of encoding music for computers.
Sure. Yeah.
And so the problem you're trying to solve is, if we're talking about generating a melody, they train the model on huge data sets of like open source data sets of primarily classical music, usually that's been transferred to the MIDI format. So it's unlikely that any one artist would have a catalog large enough to train a model, even the most prolific artists, right? So they have to train it on just to kind of learn general rules of what does, like, for example, what does Western music sound like? What kind of scales are there? How does a melody tend to evolve, right? And they use specific types of models that generally that would you call like a recurrent neural network that you could basically feed in some seed melody. So if you came up with some little melody fragment, you could feed it into the model, and then it's going to try to, based on what it's learned, continue on that melody. In addition to what it's learned, it also keeps track of what did it previously predict, so that it can, because music isn't, like, for example, if you're classifying an image, each image can be evaluated independently. Doesn't matter what came before. But if you're predicting what's the next note, you need to know it's sequential, right? You need to know what was the previous one. The same goes for language. If you have a model that's trying to generate language, a sentence, it needs to know what it predicted previously. So that's so when you're talking about sequential data, there are different types of models you'd use than if you're just doing a traditional feed forward network, I guess, where each prediction is independent of the previous prediction.
Yeah, yeah. Okay. And it's safe to say that that kind of model generation and testing takes a hefty amount of computing power?
Indeed, yes.
Okay. Got it. So I know, like Kyle mentioned at the beginning, that both of you are in the Java practice, and you're involved in, or correct me if I'm wrong, you're involved in implementing some machine learning algorithms that have been derived by maybe a team of data scientists or another developer or something. Does working with those algorithms change your job, the kind of work that you do, or does it fit in pretty well with sort of, I guess, what I'll call traditional computer science and development work?
I'd say it fits in pretty well with traditional. It's just a layer on top, like any other business you go into. You're going to learn something about, let's go to healthcare, and you learn about the healthcare business on top of whatever applications you built to scale. I'd see machine learning and this space is kind of similar. You're still building highly scalable apps, that work well with high uptime and low error rate. It's just you're doing it for a different purpose, and that's to feed trained models to some place that can deliver predictions. Make sure the data is flowing in correctly so that you can train new things. Normal kind of engineering stuff.
Yeah.
Do you have a take on that, Leif?
Yeah, I agree. I mean, the role we've played, I think it's safe to say neither Brian or I are data scientists. We are not experts in all things machine learning. I think in the setting where we've seen this whole bringing machine learning to production successful, you need to have a cross-functional team that can work closely together. So we had data scientists that we work closely with, and we're kind of playing more of a traditional engineering role, maybe data engineering role as well, in enabling, in getting the data where it needs to be, to ingesting that data, making sure it's in a data warehouse, whatever, available to data scientists. And then once the model is trained, how do we actually bring that to production and serve predictions up from your model in a performant way and scale it out, which, that wouldn't be necessarily in the wheelhouse of the traditional data scientist role. It's more of an engineering capability. So.
Okay, so would it be safe to say, let's think of data science as more the statistical side, you're training your data, you're testing out different models, and the engineering side would be like, hey, pass me off the algorithm. Once you're satisfied with it, I'll implement it and then make sure I can get you data back so that you can keep doing your job with the heavy math fun,
Yeah.
to use the technical term.
Yeah, I'd say that's pretty accurate.
Okay.
And
I think
we did have the opportunity to actually learn stuff about stuff that goes on behind the scenes, pull back the curtain and see some of the statistics, and half of it went over my head. But that was really fun to try to learn some of that stuff, and gave me an amount of respect for the people that do it, the data science that do it.
So besides having engineers who are, open to supporting machine learning, what are some of the other things that a company might need to be in a good position to start digging into machine learning? Because I asked that because I think there are a lot of articles over the past, years or so saying you just need a data science and then you can do machine learning. And that is a single verb that seems to encompass a lot more than it might seem at face value. So are there things that you've found, either other team members or other tools or other, project practices that enable machine learning to be more successful than not? I deliberately made it a really broad question.
So what-
you don't have
what-
to answer it in totality.
Yeah. So what do we need in place to say, yeah, we can do machine learning,
Yeah.
and then how do we make sure it's successful? Kind of.
Yeah.
Is that sort of okay?
Yeah.
I mean, I think I mentioned it earlier, but first off, before you even say we need to do machine learning, have a problem that you want to solve, and then you can decide, is machine learning the answer? Like, if it's a simple problem where a rule-based approach can solve it, like maybe machine learning is a bit heavy, right? Start simple, and even when you get into machine learning, start simple. Is there a simple solution where we can see some results, positive or not? Hopefully we deliver some value and we see some positive results. Dip your toes in the water first. Let's see. I mentioned this earlier as well, but okay, we have a problem. We think it's a good candidate for machine learning. Do we know what data we have available? Because sometimes getting access to data is really difficult in a big organization.
Yeah.
You don't know where it's coming from. It's not all in one place. Do we have the data we need? Do we know how we want to measure success? Just really defining a problem in a traditional sense, like you would for any software project, is important here.
And it seems
So
like
that-
you might need to have some buy-in from, maybe the higher ups in a company, because there is a certain level of, okay, can you give me a pile of data and let me play with it for a bit? Like, it's not you will immediately have results, but you need to do some research and experimentation.
Right, and I think that kind of ties back into do we need, if this is a huge difficult problem, can we just take a little, like a sliver of that and try to deliver something to kind of hopefully gain the trust of that leadership more? Because if you just go dark for months and months with nothing to show for it, which can definitely happen, all of a sudden your project is done, right?
So can
Leadership says
machine
no.
learning? Yeah, can machine learning kind of be used to feed like business intelligence? And like I'm thinking, like one thing that people like to see is dashboards and KPIs and bells and whistles and gadgets and all that kind of fun stuff. And like, would you use machine learning if you don't know what those magic numbers are and how to measure them? Is that something where you could just point it at all your data and do something with machine learning to kind of put that together? Or is that a big ask?
That's hard. I don't know. You'd have to know more about the specific problem you're trying to solve. But I imagine anybody trying to do that would have a limited data set. Like, what's your data set? Like the last 10 years of company data. So it's just your company. And assuming you collected all that data, it's not a very big data set. So maybe machine learning is not great for that. But then again, maybe there's other pieces, some small chunk of BI that you could automate. I can't think of an example off the top of my head though.
I know
Yeah,
some. Oh, go ahead. Sorry.
I mean, certainly some business intelligence platforms are starting to integrate or build some some machine learning into their platforms. Probably many of the major players. I won't name off specific names because I don't know specifically what capabilities each one has, but I know that I've seen some demos of some BI platforms that are integrating machine learning. I mean, certainly something like a anomaly detection, if you just throw a data set at it and find, something that doesn't look like the others, that's something like that seems like a general problem that maybe machine learning could solve. It definitely seems like there's some blurring between business intelligence and machine learning. Like there's overlap for sure. It's not just I guess the BI products aren't just delivering your traditional reporting capabilities anymore.
Yeah, and
So
I know some of them have the capability. So, like, given a dashboard, some of them have the capability to have individual users basically run through what if scenarios to start to use pre-built models to do financial forecasting or something that can help them drill down to insights more quickly. But obviously, the specificity of the problem and the size of the data really impact how accurate that tooling is.
I think
So,
maybe one. Oh, go ahead.
I was just wondering if there's ways, because you talked about a team and, like having data scientists and developers and engineers kind of work together. Are there any like pre-existing tools or apps or things like that available to kind of jumpstart or kind of fill in for any of those different team members that an organization could tap into?
Well, I'll leave the organization for now. And if you're an engineer and just want to have fun, go check out some TensorFlow examples. There's a lot of workbooks. You can just go write a little bit of Python and feed some data through. Go have fun with it. Organization level is a totally different story, though.
So I know that, the major cloud providers have a lot of, have many products, suites of products that aim to do just that and allow you to bring in machine learning capability without necessarily having all the expertise in-house. I guess I would still kind of, I still kind of feel that it would be important to have that capability. But admittedly, I haven't really played around a ton with, like, for example, SageMaker, that whole suite in AWS. I have with some of the Google Cloud stuff a bit more. But so like there are some of those kind of ML as a service offerings out there, which, some of them are very tailored to specific use cases. So might be something worth checking out. But I still think having somebody who understands what's going on and how you would attack those types of problems from a data science perspective would be very helpful.
Yeah, you still need to clean your data, right, intelligently. That takes human intervention, and you still need to figure out if the model that it produces is actually doing the right thing that you want. Yeah, it's not just exactly just plug and play.
Sort of like you can have like Elastic Beanstalk on AWS side. Like, well, there's your app. It's just super easy, but you'll still need engineers to understand how to fit the pieces together and maintain it. Is that a fair corollary?
Yeah, set it up and feed it the right data. Yeah, all that stuff.
So we're not quite at the point where a self-driving car is going to be able to recognize cats.
Not quite.
Yeah, maybe if I try to log into more stuff and determine if I'm not a robot.
Yeah, your CAPTCHA data is standing in the way between us and self-driving cars.
Is that why it never seems to work the first time? It's like double dipping. It's like, we're going to get you to do 2 of these. You did get the first one right, but we need the extra help. So
yeah, remember those probabilities? The 95% confidence, that's not probably going to cut it when you're deciding whether something's a red light. So I think that's why it's taking a little bit longer.
Yeah.
Yeah, they don't want to fail. Like, you can only have so many failures before they want to just scrap the whole thing and go, this is just bad. This is a costly endeavor that we don't want to do. But that's self-driving cars. Lives are on the line. For your stuff, just the recognizing cat problem for, trying to provide relevant data or suggestions or like finding anomalies, stuff like that. I can see like some like usefulness in content organization tools. Like scan through these drives and find out which things don't belong.
Yeah,
and
I
that
think
kind
that's
of
that's a great use for that. I know do you have any experience with that?
doing it manually, trying to get business users to do it manually.
It's called analog
That-
learning.
That is that's a gift and a curse. Yeah, we'll get there, but we need to have like several meetings just to get you to do it. Just to say, okay, we really need to help you because you can't make this. Like they have to train me first. I'm the machine that has to be able to recognize, what's relevant for you and what's not.
Do you know what a cat is?
I've been asked that so many times lately. I know it's not Batman.
It's the other
I
one.
think that's a really good application problem space because that's a straightforward one, identifying which documents would fit a certain type of document bucket. That seems pretty
Yeah,
straightforward.
like finding a set of common keywords and then finding things that don't have anything in that set and then calling those out as anomalies. And then based on that, have some kind of human intervention to go in there and look at the anomalies and go, okay, this folder is supposed to contain these types of things. Is this your card? Like, nope. Is this your card? Nope. Well, this one is. Okay, why is that? What are the characteristics that make this like the others, even though it doesn't share any of those keywords? And then that's where your kind of retraining comes in. I think I understand machine learning now. I don't know what happened.
Well done, guys.
It really
It's
worked.
It's not magic. It's just it's statistics all the way down, turtles.
That's awesome. All right.
Caveman
Well, I
is
feel
now
like we've
math
accomplished our task of getting Kyle to learn what machine learning is. That's kind of the whole point of today. I learned what cryptocurrency was a while back. That was a valuable one too.
That was great. Great questions.
Awesome. Well,
Yeah,
thank you,
perfect.
gentlemen, for being here and telling us about machine learning. And of course, thank you, Al. And that was the SDG podcast. If you want to get a hold of us, drop us an email at thepodcasters@solutiondesign.com. Until next time, say goodbye, everybody.
Goodbye, everybody.
Bye, everybody.
Bye.